In this session, we will see about how can we create an binary search tree. So we have three rules are there. So always the first value. Okay, for example, this is a main function. So for this main function, so we have gotten this number of values to be inserted in a binary search tree. So initially my root will be null. Root will be equal to null. Then I have got this number of values to be inserted in a binary search tree. So first 50. 50 is a number. So since that's the first 50 is a number that will be entered as a root node. Then the next value, the 30. 30 value will be compared with the root node. If it is lesser than the root node, it will be stored in the left side. If it is greater than the root node, it will be stored in the right side. This is a simple concept. If the incoming value is lesser than the root node, I will store in the left side. If the incoming value is higher than the root node, I will store in the right side of my root node. This is the concept. So now for that, we have written a function to insert a value in a binary search tree. Only this much. So now what happens over here? So insert is a function we have been called. So in the insert function, we have got a root and then we have got a value. Okay. So now if root is null, then simple. I will put that now. I will put the first value. I will put the first value. So create node. So create node already we have done it. Okay. So for a create node, we have allocated memory space. In the data, we have stored a value. In the left side and the right side, then the value is null. The address is null for the first node. Okay. Then if root is something else, 50 is a root node now. So now what do we check? I will compare the incoming value with the root of data. Okay, the incoming value is, next value is 30. So I'll compare the 30 with the root of data. So 30 lesser than 50. So what I will do, I will store it in the left side. I will store it in the left side. So once again, the same function will be called. Same function will be called. Okay. So now what happens over here? The next value, 70, which is higher than the root node. So it will go for root of right. So now how the node will be? So 50 and next value will be 30 and next value will be 70. So then what happens over here? Next value is 20. So now what happens over here? Okay. So now it will go and search for the root. So compare the 50. 20 is lesser, goes to left side. Once again, the same function will be called 30, which is lesser than the root 30. So I will store it in the left side of my 30, 20. Okay, and the next value is going to be 40. It's compare the 50, which is lesser than the 50. It goes to left side. And compare with the 30, higher than the root. It goes to the right side. It goes to the right side. Next value 60. 60 is higher than the root. It goes to right side. Then it compare with 70, which is lesser than the 70. It goes to the left side of 70. Next value is 80. 80 is higher than the 50. It goes to right side. And then 70 becomes root now. So 80 is higher than the 70. Goes to right side. So then 80. Next one is 10. Lesser than the 50. Lesser than 30. Lesser than 20. So now what happens over here? It comes and store in the left side of 20, 10. Next one is 35. So lesser than the 50 comes here, and then higher than 30 comes here, lesser than 40. It goes to left side of the 40, and then 45, lesser than the 50, left side, higher than the 30, higher than 40. So and then 45. So this is how the binary search tree will be gets created and then inserted. So for the insertion, this is a function. This is a function. Once again, it's a recursive function. So at first, initially the root will be 0. So when the root is 0, it will call the create node. Then it will go and compare with the root of data. If it's lesser than, then once again, the same value will be gets called once again. The same insert function will be called once again. In the first insertion function, this will be root node. The second insertion function, this will be root node. And the third insertion function, this will be root node. It will compare with once again, again and again, and then it will store in the left side of the data or in the right side of the data. So this is the function of the insertion of a value in the binary search tree. Then once you insert a binary search tree, once the data has been added up in the binary search tree, then we can perform either three of the traversals, either in order, pre-order, or post-order. So here in this example, we have given the in order traversal. So what happens over here? It will visit the left node and then root and then the right. So in order root of left, at most left it will go there and then print the data and then it will go to the right side and then it will print the data. That's in order traversal. So for traversals already we have seen. If not, please check the previous one. So this is in order traversal. So this is the main function. We have done the insertion of data and then we have performed the in order traversal. So this is how you can create a binary search tree. In the next session, we will see how can we delete your data in the binary search tree. Okay, thank you.